of the things I was looking at is when we did division, we said we can subtract our exponents. So some of you did that, and if I was looking at that, I should have had x to the fifth, right? I had some people write this out in expanded form. They wrote 17 x's, right? That's 17 of them, divided by 12 of them, and they canceled off all the like ones. Could you have done that? Yeah, exactly like what we did in our work. So could you have done it with expanded form? That's what I had a couple people do here for m to the third and m to the fifth. So when you think about that quiz, if you ever get stuck and you're doing a quiz on this unit, what does m to the third mean? M to the third means I have 3 m's. What does m to the fifth mean? It means I have 5 m's. That means a total of how many m's? I have 8. Just wait for a minute. This 3x to the second, this is telling us to write 3x times 3x. So when I'm looking at that, I then want to rearrange it with my like terms. I need you guys to focus up here. So I got 2 3's, which gives me 9, and then the x's, the most common answer I had was 9x. Question?
So you circled on my x5.
Yeah. It's probably because I was looking for your answer. And you got it right. It doesn't have a check mark, right? So sometimes you have so much work, and if you guys don't circle your answer and I'm looking for the answer, I might try and circle it so I can see where it is. Okay? So making sure, if you're really struggling with this, today we're going to do a little more with negative exponents. We're going to do a little more work as we are looking at that 0. And then tomorrow we get into the multiplying powers. Okay? And then on Thursday we do more practice with that. So page 8 is where you should be at on your notes, please. As you're looking at page 8, again at the top it says, use properties of integer exponents to simplify and know anything to the 0 power is 1. What is anything to the 0 power?
1.
Anything to the 0 is? 1. So this is really important, right? So 0 and negative exponent. Here's what it's going to look like when they show it in an algebra book as you're looking at this. They say anything, so they use a to the 0. It could have been any variable to the 0 is equal to 1, except when it's 0. And we saw that yesterday. That's undefined. 5 to the 0 is 1. We are not going to take a look at this video. They just kind of keep going through a lot more stuff. I'd just as soon give you some time to work, and maybe towards the end we might show that. As I'm looking at this one, a negative exponent. Any term to a negative power, please make sure you circle, put a box around the reciprocal of the term with a positive power. So a negative power is the reciprocal, if we are reading that, of a term with a positive power. A to the negative n is going to be 1 over a to the n. 2 to the negative 3, 1 over 2 to the third. Now in tonight's homework, I'm then going to ask you to write it this way. 2 to the third, and some of you might need to multiply this out, or you might take your calculator out, and on your calculator you have this caret key. Some of you have a y to the x, and if you don't remember that 2 to the third is 8, that was one that we memorized, you might put it in your calculator of 2 raised to the third. You might use the y to the x key and put 2 raised to the third, hitting your equal sign to get that answer of 8. Okay? Again, what if it's in the denominator? 1 over a to the negative n. We're going to write it as a to the n. And if it helps you to think of reciprocal and put it over 1, put it over 1. Here, 1 over 2 to the negative 4, 2 to the 4 over 1. 2 to the 4th, well, if I know 2 to the third is 8, 2 to the 4th is going to be 8 times 2, and 8 times 2 is 16, if I was looking at this. Okay? So, kind of just to make sure you're explaining that. We are going to watch this video. This video kind of talks about when it's a negative base, because the first 4 questions in your homework are going to ask you, is the answer positive or negative? So we're going to kind of watch this video as you are taking a look. And as we watch this,
this calculator says negative 3 to the second power is negative 9. Do you agree or disagree? Let's explore. this lesson, you will learn to apply exponents to negative bases by becoming familiar with different notations. Remember, an exponent tells you how many times to multiply a base number by itself. So we can summarize a multiplication statement of 2 times 2 times 2 times 2 with 2 as the base and 5 as the exponent, also called a power. So let's look back at our question. If negative 3 is the base and we raise it to the second exponent, that should mean we multiply negative 3 times itself and get 9, right? So why does our calculator say negative 9? The reason is that calculators are very sensitive to notation. It turns out when we write an exponential expression this way, negative 3 is not the base, 3 is. This notation indicates we multiply the base of 3 times itself twice, then apply the negative sign to the result. So we get 9 after multiplying 3 times 3, but then we apply the negative to the front and get negative 9. This is what the calculator is doing when it gives us negative 9. In order for the base to be negative 3, we must have a negative 3 in parentheses. This notation shows us we are to multiply a base of negative 3 by itself twice, which results in a positive 9. When we enter notation in the calculator this way, we see that the calculator now agrees the answer is 9. This notation is standard for any base. If there is a negative sign in front of a base number, this does not mean we have a negative base. We raise the base to the exponent, then apply the negative to the result. The only way to have a negative base is to have the negative and the base inside.
So kind of be watching for that. That's what our first few questions are going to be on.
Outside the parentheses. Let's try this in a few examples. Here we are asked to evaluate, or find the value of, negative 2 to the third power. Since negative 2 is in parentheses, negative 2 is the base number, we multiply by itself 3 times. This simplifies to 4 times negative.
So do you think our answer positive or negative? 3 negatives. What do you think? Should be negative. The first 2 multiplied and gave us a positive, right? Times a negative. So as we kind of take a look and thinking about these.
Which results in negative 8. In example 2, the base is not in parentheses, so the base is 3, not negative 3. We'll apply the negative to our answer. So first, we write a multiplication statement with 4 through.
So what are we thinking? Positive or negative? There's 1 negative, right? 1 negative, our answer should be?
Then we can multiply these first 2 3's to get 9, and these second 2 3's to get another 9. So we multiply these 2 9's and get 81. Then just apply the negative to the front and get negative 81. Let's do one last example. Since our negative 1 is in parentheses, that is our base. When we multiply negative 1.
What do you think? Positive, negative?
Positive.
Positive. Anyone think negative? So we're going to kind of look at that. Think about the number of negatives.
1 by itself 5 times. These first 2 negative 1's multiply to be 1. The next 2 negative 1's will also pair up to multiply to another positive 1. Then there is just one last lonely negative 1 that multiplies times the 1 and the 1 and results overall in negative 1. In this lesson, you have learned how to apply an exponent to a negative base by becoming familiar with different notations.
So as we are looking at this, if I have a negative base and it is to an even power, that means I take 2 negatives times each other. What am I going to get? I take negative 2 to the second power. That means 2 negatives. Negative times a negative is positive 4. How about if I take negative 2 with a parenthesis to the 6th power, or even negative 1 to the 6th power? I'm going to be multiplying 6 negatives together. Every 2 becomes a positive, right? So if I have a negative base to an even power, my answer is always going to be positive. Please write positive answer. And you can check that by putting it in a parenthesis when you do this on your calculator. Now, we just saw negative 1 to the 5th. Brad, you're writing this? We just saw, as we are looking at these, as we are writing in that video, when they have a negative number to an odd power. So if I think of, I have negative 1 to to the first, well, that's just -1. If I have -1 to the 5th power, that's what we just saw in the video. We saw that came out to be a -1. And we would think that any time this is an odd power, our answer should always be, in this case, negative. So if it's a negative number to an even is 2, 4, 6, 8, 10, correct? If it's a negative base to an odd, 1, 3, 5, 7, right? So we're thinking of those numbers. This is going to be a negative answer. So we are taking a look. First thing you always want to take a look at is it in a parenthesis or not? Because that makes a difference, just like they were saying in the video. So these first 1, 2, and this one over here all have it in a parenthesis. So we're going to take a look. 15 is an odd number, so our answer should be -1. That means I'm going to have 15 negatives ones. Well, 14 of them multiply to give us just 1. 1 times -1 is going to give us a -1. So what I want you to do is looking at these last two down here. We're going to come back to this one. Talk to your shoulder partner or the person sitting by you and tell me if it's going to be what our answer should be for that. Off, 22, even or odd?
Even.
This is an even. So I have a negative base to an even. We think this should be positive. And if I'm taking 1 to that power, that means 1 times 1 times 1 times 1. This should be a positive 1. Okay? If you thought negative, you've got to be careful. We were looking at an even power. Whereas here, we were looking at an odd power, right? It doesn't matter what the inside the parentheses. Both of them were negative in the parentheses. Here I have -4 to the second. Now in my homework tonight, the first 4 questions, I just ask you, is it positive or is it negative? So if I was asking you for this one, -4, because 2 is an even power, our answer should be positive. And now what am I really doing? I'm taking -4 times -4. That gives me a positive 16. This question, there's no parentheses, so I can't use this rule and say that it's going to be positive. Because I'm going to be thinking of this as -1 times 4 to the second, is how they said in that video. So 4 squared is 16, and this answer would be negative, and it's actually going to be -16. Okay? So the first one was negative. The next two down here were both positive, and then we had a negative as we are taking a look at that. Now we're going to take a look at that simplifying with our exponents with a negative exponent. So as you are taking a look on page 9, and we really just have page 9 and then page 10 in our notes that we're going to be looking at today. So the first one, again, if there's no denominator, please put them over 1. So this one is a fraction. It already has a numerator and denominator. The third one does not have a denominator. Put it over 1. Keep in mind that if you don't have a exponent, a lot of times the exponent is 1 if there's nothing there. So I'm starting with 1 or x to the -9 over 1. If I am looking at that and simplifying, negative exponent, I have to do reciprocal. 1 over x to the 9. Done. That's as simple as what some of your homework will look like. So I'm taking a look at that next one. And as I take a look at the next one, Autumn, I have 1 over n to the -3. The n to the -3 is in the denominator, so reciprocal would move it to the top. And I'm now, instead of -3, going to put n to the +3. And if you'd like to put a plus in front of it, you can just write 3 over 1. And could I just have written n to the 3rd for my answer? Yes. Could I leave it like this? I will not mark that wrong if you would circle that answer. Both make sense. Okay. So I look at that next one, and Josh, when I look at 4, what's the exponent of 4? What power is it?
-3.
Ooh, the c is to the -3. What's the 4 to? There's no exponent there. What's there? There's nothing there.
0.
Not 0, because 4 to the 0 would be equal to 1, right? Anything to the 0 equals 1. So how do I get it to equal 4? Maddox, what were you saying?
1.
4 to the 1st. So please put behind the 4, put an exponent of 1. C is to the -3, which now means, Tyler, B is going to be to what power?
1.
b is also going to be to the 1. So the only one that I'm looking at moving at this point, the only negative exponent, is my c. That's the only one that's going to move. So when I write my answer, Cameron, I'm going to have 4 and b. And if it helps you to put the exponent 1, put the exponent 1, but you don't have to have those. Cameron, what happens to c to the negative 3? And if it helps you to look at what we did with x to the negative 9 and n to the negative 3. So when I had x to the negative 9 in the numerator, we moved it to the bottom. So here, guys, quickly, what are we going to do with the c? It's in the numerator. So I'm going to keep it in the numerator. No. So if I move it to the denominator, c to what power? C to the what? C to the 3. C to the third. Okay. So when I look at this next one, and again, I think for some of you, just having the answer written without the ones might be a little easier, but having it written with the ones, I would take either one of these two answers. These are the same thing, right? So when I start looking at that, I have the 2. And if I'm looking, Ivy, at 2, 2 is to what power? No exponent there. So what power would you say? To the 1. So that's probably the biggest mistake, is that I'll have people move both of these. Should I move the 2 if I'm looking at this problem? No, the 2 should move. Ivy, what's going to happen to a to the negative 3? Going to the numerator, and it's now going to become, instead of negative 3, positive 3. Do I have to put a denominator of 1? No. Could you? Sure, but you can just leave it like this. If you had 2a to the 3rd over 1, I'd count that correct also. Okay? So, we're looking at that last one, Maddox. What do I need to move, and when I move it, what's going to happen? N has to move. So it's in the numerator. I got to go to the denominator. N to what power now? 5th. So it was negative. Whenever you switch it, it becomes just the opposite, positive. Okay? Brad, what do I want to do with the M?
Put it on top.
Because it was negative down here? This is M to what power? Second. Positive? Yeah. So should we move anything if it's positive? Someone said, yeah, but if we move this down, we should just switch these around. I should take the reciprocal of both. No, 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 no. So here's the thing. This stays down here M to the second, because what this problem really looks like is this, if you think of it this way. This is n to the negative 5 over 1 times 1 over m to the second. So all we did was move this down, right? Put it in our denominator, and in the numerator, we're going to keep it just the 1. But we are the biggest mistake on this, and I'll tell you, algebra students do it too. Next year, you'll probably get into when you're simplifying with exponents as you do this. It is super easy to just go, well, if I move one, I better move the other one. So just be really careful that you acknowledge and notice that the positives never move. Positives, powers of 1, they stay exactly where they're at, okay? So our final answer could be written this way. What if when you look at the answer in the back, they put it as m to the second, n to the 5th? Are these the same? Yeah, because this is just being multiplied here. Make sure you don't all of a sudden put a plus sign in here. There's no plus signs in these when you are taking a look at it. So we have on the bottom of that page 3 more or 4 more that we are going to take a look at simplifying. Okay? Keep in mind, if there's no exponent, I'm going to have you, as we are practicing, putting the exponent as 1. So we are starting off, Kira, and I have 3 to the negative 2 over n to the, what power? N to the 1. Which one am I moving? 3 to the negative. When I move that 3 to the negative, as I move that, please write down what you think your answer is. We're going to take a look at it up here. Does the n move? No. So my answer looks like 1 over 9n. Someone said, well, I didn't do 9n right away. I rewrote it first as 1 over 3 to the second n. I agree. But 3 to the second, n is not to the second, just the 3. Okay? So let's take a look at the next one as we are looking at that. Jaden, as we are looking at that next one, 3 is to what power? Wait. 3. The x is to the negative. 3 is to the first. Y is to the first. Okay? So the only one I am moving, Jaden, is what? The x, which gives me what in the numerator? Should I have anything in the numerator besides the 3? Does that make sense?
Oh,
Numerator. Okay. So on the top, 3, and then what's going to be on the bottom? The denominator.
xy, or x2, or x to the power of 2y.
X to the power of 2y. X squared y. Okay? So the only thing moving is your negative exponent. Negative exponent. So, I'm looking at the next one. Kaizen 6 is to what power? First. Negative, 0. We love something to the 0. Isabel Garner, d to the 0 is 1. So I got 1 in my denominator. 6. Should I move it or keep it, Morgan? Keep it. How about the a? What are you going to do, Morgan, with the a? Move it. If I move it to the denominator, it becomes a to the first. Jared, how about the c? Do what? Keep it with the 6 because it's a positive exponent. This is a positive exponent. Nope. The 6 was positive, so we got to say this was my d to the 0 was 1. The negative moved down. What do I have to do with the negative 3? Okay, and I'm going to have c2 positive 3 now. So my final answer is 6. Do I have to keep a 1 out in front of that? You could. It's never. I'm never going to mark that wrong. A and c to the third for my solution. Okay. Why did we move the 6? Because it was a positive 1. Only moved the 2 that were negatives got moved down, and it became a positive power. So again, this doesn't have a fraction, so I'm going to put it over 1. That's my hint as you do your homework and do it the same way. So again, I'm starting out, they all have exponents. 2 to the negative 3. Stay on top or bottom? 2 to the now what? Okay, wait. It was negative 3. Positive 3. So 2 to the third. I'm looking, Amy, at x to the second. Keep it where it's at. Move it. Keep it x squared on top. Grady, I'm taking a look at z. I have z to the negative 7. How? Z to the 7, put it to the bottom. Okay? So live, I have x to the second, I have 2 to the third. 2 to the third, you guys can use your calculator if you need to. That means 3 2's multiplied. What do I end up with? 2 times 2 times 2, 8. And then I'm going to have z to the 7 as my final answer. Okay? Questions as you are taking a look. Use exponential notation and working with all these. You're going to see in scientific notation soon, but it says if we're using exponential expressions, a population of marine bacteria doubles every hour. So doubling would mean times what? What number when we think of doubling? We think doubling times 2. That's why the base here is 2, right? So it doubles every hour under controlled lab conditions. The number of bacteria can be modeled by this expression, where H is the number of hours. So we know this H stands for our hours. after they started measuring the population. So they said, okay, we got 1,000 bacteria. We're going to keep measuring it and see what happens, if we can look at it. So it says evaluate. So what we want to do is please write down 1,000 times 2, but h is equal to 2. So instead of an h here, we're going to put to the second. Well, 2 to the second is how much? 4. Brad, you right with us? So we got 1,000 times 4. So the question is, what does this mean? We have 4,000 what? Bacteria after how much time?
2 hours.
After 2 hours. So now we're going to take a look at the 0. Well, what do we think our 0 is? That was at the where? At the beginning, right? So 1,000 times 2 to the 0. If I'm plugging in 2 to the 0, 2 to the 0 is really 1,000 times, everyone, anything to the 0 is?
0.
Ah!
1.
I know. You're going to make that same mistake on the test, though, and on your homework. So I just make sure you check your homework as you do this, right? So this is just 1,000. So we're looking at 1,000 bacteria, and I already heard some of you say it was at the beginning, right? At time 0. Well, now we got h to the negative 3. That's our last one. So using our expression, we have 1,000 times 2 to the negative 3. We're going to use your calculator. Everyone knows how. But this problem really is saying 1,000 times 1 over 2 to the 3rd. Do you agree? That's what that negative exponent tells me to do, the reciprocal. Well, on my calculator, when I take a look at the calculator, and I want to put in this exact expression. So first off, let's put in 2. And on my calculator, I have x to the y. Like I said, yours might be that caret key, so try it. So I'm going to take 2, and I'm going to put this part in first. There's calculators up here. Some of you that don't have them, walk your butts up here and grab a calculator. You want to make sure you can get this. And I'm going to put in 3, and on my calculator, I have to put the plus minus after I put the 3 in. So notice this is saying 2 raised to the negative 3. If I'm putting that in, it should be a decimal, because that's 1/8, 0.125. Check on your calculator and see if when you put in 2 to the negative 3, you get 0.125. And if you don't, check with me so I can help you. So make sure as you put it in, 2 to the negative 3, you get 0.125. You could have had 1/8. You could leave it as 1/8. What it did is it kept it as a fraction on your calculator. That's fine. And on your calculator, if it comes out as 1/8, you should have a button that says to change it to a decimal. So you could change it to the decimal, and it should come out to be 0.125. Anyone not get this? Okay. Now take it times 1,000. So you have this on your calculator. Just go times 1,000. Right. So we multiply it by 1,000. And if we are multiplying it by 1,000 at this point, when we take a look at that, we got 125. So the question is, if I was looking at this, this is the same as 1,000 times 1/8, that's that 0.125. How much did we end up with? 125 bacteria when? 3 hours before they started, right? So 3 hours before they started measuring. If we are taking a look at that, it's super important that you know how to put them in your calculator with them, because sometimes those are nice ways to check to see if you got the right answer, okay? We are not going to have decimals on our calculator or on our homework. So if I would just give you this 2 to the negative 3 on your homework tonight, and the first question, is that going to be positive or negative? 2 to the negative 3. Positive or negative? Positive. Does the negative exponent make the number negative? No. Only if you take negative times a negative, like if you have an odd number of negatives. This is a positive 2. What does this mean? This means 1 over 2 to the 3rd. Now, could you also put in your calculator 2 raised to the 3rd power? and hopefully you get 8, and our answer is 1/8. If you tell me this answer is 0.125, I'm gonna mark it wrong. I don't want the decimal. I want you to keep it as a fraction when you're doing homework. So your homework tonight, please make sure you circle as you turn to page 40. There's only one page, page 40. If those of you that didn't finish yesterday's homework, you want to make sure you show that